Hi, welcome to this Corbettmaths video. In this video we're going to go through the video solutions to the significant figures practice questions. If you need any extra help on significant figures, if you go to corbettmaths.com/content, so you scroll down to video 279A, that'll bring you to the video tutorial on rounding to significant figures. Alternatively, you could scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, let's have a look at question number 1. So question number 1 says, write 236 correct to one significant figure. So what that means is we want to have one digit followed by zeros. So in this case, because it's 236, we either want to choose 200 or 300. And because this number is closer to 200 than 300, our answer would be 200. So 236 rounded to one significant figure, so one digit followed by zeros, then we would have 200. Another way to consider it is because we've got 236, we want to round to one significant figure, so we want one digit, and we want to make the rest of them zeros. Because then the second significant figure is a 3, we round down, so our answer would be 200. Okay, let's have a look at question number 2. So question number 2 says, round 74.86 to one significant figure. So that means that we want one digit followed by zeros. And because we get 74.86, our choices are either going to be 70 or 80. And because 74.86 is closer to 70 than it is to 80, our answer would be 70. Again, we could look at our 74.86, so we could write 74.86, and then we've got our first significant figure, we then put our dotted line, and then we're going to look at our second significant figure. It's a 4, so we round down, so our answer would be 70. Okay, let's look at our next question, question number 3. So question number 3 says round 6,793 to one significant figure. So our choices will be either 6,000 or 7,000 because we want one digit followed by zeros. Because it's 6,793, that's much closer to 7,000 than it is to 6,000, so the answer would be 7,000. Again, we could look at our 6,793. We've got our first significant figure. We could do our dashed line, and then we could look at the second significant figure, which is a 7. Because it's a 7, we round up, so we would choose 7,000. Okay, let's look at question number 4. Question number 4 says round 24,514 to one significant figure. So because we want one digit followed by zeros, our choices will either be 20,000 or 30,000. Because it's 24,000, that's going to be closer to 20,000 than it is to 30,000. So the answer would be 20,000. Again, we could write our 24,514, and because we want to round it to one significant figure, we can do a dashed line after the first significant figure. We can look at the second significant figure, which is a 4. That means we're going to round down, so answer would be 20,000. Okay, let's have a look at question number 5. Question number 5 says, write 3,540 correct two significant figures. That means we want two digits followed by zeros. So in this case, because it's 3,500, our choices will be either 3,500 or 3,600. And because it's 3,540, that means we're going to choose 3,500 rather than 3,600. So our answer would be 3,500. Alternatively, we could write our 3,540. We want to round to two significant figures, so we want two digits followed by zeros. And because our third significant figure is a 4, we don't round up, so our answer would be 3,500. Okay, question number 6. Question number 6 says round 17,635 to correct to two significant figures. So again, we want two digits followed by zeros. So in this case, we either want 17,000 or 18,000. Because it's 17,600 and something, I can see that's closer to 18,000 than it is to 17,000. So I would just write down the answer, 18,000. Again, if you wanted to, you could write down 17,635. We want to round this to two significant figures, so we can put a dashed line after the second significant figure. We look at the third significant figure, which is a 6. Because it's a 6, we round up, so our answer would be 18,000. And then we've got two digits followed by zeros. Okay, let's look at question 7a. So question 7a says round 506,452 correct the two significant figures. So you want two digits followed by zeros. Now here we've got 506,452. So that means our choices will either be, because it's two digits followed by zeros, we've got a choice of either 500,000 or 510,000. Now because we've got 506,000, that's going to be closer to 510,000 than it is to 500,000. So my answer would be 510,000. So that's how I would do that question. Alternatively, we could write our 506452 like so. We want two digits followed by 0, so let's put a dashed line after the second digit, the second significant figure. And we've got 50, and then the third significant figure is a 6. Because it's a 6, we round up, so our answer would be 510,000. Okay, question 7b. We've got the same number, 506,452, and we've been asked to round that to three significant figures. So that means we want three digits followed by zeros. So in this case, we'll either have 506,000 or 507,000. Now, because it's 506,452, that's closer to 506,000 than it is to 507,000. So that means our answer would be 506,000. Alternatively, we could write down our 506452. We want to round it to three significant figures. That means we want three digits followed by zeros. So we're going to look at our fourth significant figure, which is a 4. Because it's a 4, we don't round up, we round down. So answer would be 506,000. Okay, let's have a look at question number 8. So question number 8, now this time we've been given a number which is a decimal number, so we've been asked to write 0.0683 correct to one significant figure. Now in this case, because we've got a decimal number where we've got 0.0 and so on, whenever we look at our significant figures, we start counting our significant figures from the first non-zero digit. So here we've got 0.0683, so we ignore these 0.0 at the front, so this digit here is the first significant figure. So in this case, whenever we're rounding this number to one significant figure, so our choices in this case will either be 0.06 or 0.07. Now 0.0683 is closer to 0.07 than it is to 0.06, so in this case our answer would be 0.07. So that's how I would do that question. Alternatively, we could write our 0.0683. We want to round it to one significant figure. We ignore these 0.0s at the front. This is our first significant figure, so we put our dashed line after it. We look at our 8, and because it's an 8, we round up, so our answer would be 0.07. Okay, question number 9, we've got 0.1826, and we've been asked to round that to two significant figures. So because we've got 0. We ignore those, and we've got 1826. We want to have two digits that are not 0, so we're going to either have 0.18 or 0.19. Now because it's 0.182, that's going to be closer to 0.18 than it is to 0.19, so the answer would be 0.18. Alternatively, we could have done 0.1826. We want two significant figures, so we put a dashed line after our two significant figures. Remember to ignore the 0 point. So we've got 18. Now, because the next digit, our third significant figure, is a 2. That means we don't round up, so our answer would be 0.18. Okay, let's have a look at our next question, question number 10. So question number 10a, we've been asked to round 41,982 to one significant figure. So that means our choices will either be 40,000 or 50,000. This is closer to 40,000, so our answer will be 40,000. Alternatively, we could write our 41982. We want one significant figure, so we want one digit followed by zeros. Our second significant figure is a 1, so we round down to 40,000. Okay, next, part B, we've been given the number 8,812, and we've been asked to round that to one significant figure. So again, our choices will either be 8,000 or 9,000. That's closer to 9,000, so our answer would be 9,000. Alternatively, again, we could write our 8812. We want to round it to one significant figure, so we look at the second significant figure, which is an 8, and that means we're going to round up to 9,000. Okay, next we've got round 0.0761 to one significant figure. Now here we want to round this to one significant figure, so our 0.0, we ignore those. Our first significant figure is the 7, that digit, so we're either going to have a choice of 0.07 or 0.08. Because 0.0761 is closer to 0.08 than it is to 0.07, our answer would be 0.08. That's it. Alternatively, we could have written 0.0761. We want to round it to one significant figure. Ignore the 0.0, so we've got our 7. The digit after that's a 6, so we round it up, so our answer would be 0.08. Okay, let's have a look at part D. So part D says round 9.99 to one significant figure. So in this case, we've got 9.99, so our choices will either be, remember, we want to have one digit followed by zeros. So in this case, we'll either have 9 or 10. Now, because it's 9.99, it's much closer to 10 than it is to 9, so answer would be 10. And we've got one digit followed by zeros. Alternatively, we could have written 9.99. We want to have one significant figure. That's one digit followed by zeros. Now, if we look at the second significant figure, the 9, that means we're going to round up. And whenever we round our 9 up, we get 10. So answer would be 10. Okay, our next question, question 11. Question 11a says round 254 to two significant figures. So that means we want two digits followed by zeros, so we're either going to have 250 or 260. In this case, it's going to be closer to 250, so the answer would be 250. And again, we could have written 254. We want to round to two significant figures, so we put a dashed line after the second significant figure. The third significant figure is a 4, so we don't round up, we round down to 250. Okay, next we've been asked to round 75,301 to two significant figures. So we want two digits followed by zeros. So our choices will be 75,000 or 76,000. I'm going to choose 75,000 because it's closer to 75,000 than it is to 76,000. Again, we could have written 75,301. We want to round to two significant figures, so we have two digits followed by zeros. And then we look at the third significant figure, which is a 3. That means we round down to 75,000. Okay, let's have a look at part C. We've got round, and I hope I said enough zeros here. We've got 0.001921 or 0.001921. I've been asked to round that to two significant figures. So that means we're going to ignore our decimals at the front, our 0.000 and so on, and we just want to have two digits. So we've got 0.00019, so that's our two significant figures. And then we've got 2, that means we're going to round down. So we're not going to round up to 20, we're going to keep it as 0.00019. And again, we could have written our 0.0001921, put a dash after our second significant figure. And remember this 0.000, you ignore those, and we've got our 19. The third significant figure is a 2, so we don't round up, so we leave it as 0.00019. Okay, let's look at our next question. Question number 12, we've been asked to round 0.709 to one significant figure. So again, we're going to ignore the 0 point at the front. The first significant figure is a 7, so our choices are either 0.7 or 0.8. The next digit is a 0, so our answer would be 0.7. And again, we could have done 0.709, put a dash after the first significant figure. Remember to ignore this 0 point. The next digit is a 0, so we don't round up, so our answer would be 0.7. Okay, part B says to round 84,472 to three significant figures. So we want three digits followed by zeros. So our choices will either be 84,400 or 84,500. Now, because it's 472, we're going to round up, so our answer will be 84,500. And again, we could have done 84,472, put a dash after the third significant figure. The fourth significant figure is a 7, so we round up to 84,500. Okay, part C. Part C says to round 12,490 to two significant figures. So we want two digits followed by zeros. So our choices will either be 12,000 or 13,000. This is closer to 12,000, so our answer will be 12,000. And again, we could have done 12490, put a dash after the second significant figure. The third significant figure is a 4, so we round down to 12,000. Okay, part D. Part D says round 5,607,012 to three significant figures. So we want three digits followed by zeros. So our choices will either be 5,600,000 or 5,610,000. And as you can see here, we've got 5,607,000. Well, it's going to be closer to 5,610,000 than it is to 5,600,000. So the answer would be 5,610,000. And again, we could have done 5607012. We want to put a dash after the third significant figure. So we've got 560, so the dash is going to go after that. Now that 0 is significant, it's not in front of the number like a 0.0 and so on, so we do count that as a significant figure. The fourth significant figure is a 7, so we round up to 5,610,000. Okay, E, we've been asked to round 0.123456 to four significant figures. So we ignore the 0 point at the front. We've got 1, 2, 3, 4, 5, 6. So the four significant figures are 4. So our choice will either be 0.1234 or 0.1235. Now the next digit's a 5, so that means we're going to round up, so it's going to be 0.1235. And again, we could have done our 0.123456. We could put a dash after our fourth significant figure, ignore the 0 point, so it's going to be there. And our fifth significant figure is a 5, so we round up. So our answer is 0.1235. Okay, our next question. So F we've been asked to round 0.961 to one significant figure. So we've got 0.9, so our choices will either be 0.9 or 1 in this case. And because it's 96, that means it's closer to 1 than it is to 0.9, so our answer would be 1 to one significant figure. Again, we've got our 0.961, put a dash after the first significant figure, which is a 9. I ignore the 0 point. And then we've got a 6, so we're going to round up, so that'll be make that 10, so we're going to have 1.0 or 1. Okay, and that's it. So 1 is our answer to one significant figure. And our last part, part G, we've been asked around 1,782,739 to four significant figures. So it means we want 4 digits followed by zeros. So we've got 1, 7, 8, and then we're either going to have 2 or 3. So it's either going to be, so it means our choices will either be 1,782,000 or 1,783,000. So because we can see it's 700, it's going to be closer to 1,783,000. So that's going to be our answer, 1,783,000. And that's it. Again, we could have written down the number, put a dash after our fourth significant figure, looked at the fifth significant figure, which is a 7, and rounded up. And that would be that. And that's it. Okay, let's have a look at question number 13. So question number 13 says, at a concert there were 7,819 fans. And in a newspaper article about the concert, 7,819 was rounded to one significant figure. Write 7,819 to one significant figure. So our choices will either be 7,000 or 8,000, and this number is clearly closer to 8,000, so our answer will be 8,000. Again, we could have written 7,819, put a dash after the first significant figure. The second significant figure is an 8, and then we would round up to be 8,000. Okay, next part, part B, says, at the concert there were 3,871 programs sold. The retailer rounded this number to two significant figures. Write 3,871 to two significant figures. So we want 2 digits followed by zeros. So choices will either be 3,800 or 3,900. Now this number is closer to 3,900, so that's going to be answer, 3,900. And again, we could have written down 3,871. We want to round that to two significant figures, so we put a dash after the second significant figure. The third significant figure is a 7, so we round up to 3,900. Okay, question number 14. Okay, let's have a look at question number 14. So question number 14 says, Holly has worked out the answer to a calculation. So she's worked out the answer to a calculation, and her teacher has asked her to write all her answers to 4 significant figures. So she needs to round this to 4 significant figures, and that's what we've been asked to do. So that means that our choice will either be 827.4 or 827.5. And as you can see, 827.47 will be closer to 827.5 than it will be to 827.4. So that means our answer will be 827.5. Again, we could put a dash after the fourth significant figure. The fifth significant figure is a 7. We round up, and that would give us our answer. Okay, let's have a look at question number 15. So question number 15 says, use your calculator to work out the value of 5.8 squared plus 7.2 cubed. And whenever I do that, I get an answer of 406.888. And then the next question, part B, says write our answer to one significant figure. So that means we want 1 digit followed by zeros. So our choices are either going to be 400 or 500. And this number is much closer to 400, so our answer will be 400. And that's it. Okay, let's have a look at question number 16. So question number 16 says, work out the square root of 62, correct the two significant figures. So whenever I type in the square root of 62 in my calculator, I get the square root of 62. And then I'm going to convert that to decimal, and that's going to give me 7.8740078774, and so on. Now we want to round that to two significant figures. So in this case, we're either going to have 7.8 or 7.9. Now you can see the digit after the 8 is a 7, so that means we're going to round up. It's closer to 7.9 than it is to 7.8, so our answer is 7.9. Okay, question number 17. Question number 17 says, use your calculator to work out the value of this and write down your answer to 3 significant figures. So let's type this in as a fraction, 2.12 multiplied by 5.2, and then on the denominator, 9.21 subtract 2.8. And whenever I work that out, I get an answer of 1.719812793. We want to write our answer to 3 significant figures. So that's going to be 1.71 or 1.72. So that's going to be much closer to 1.72 than it is to 1.71. And that's it. So the answer to 3 significant figures would be 1.72. So question number 18, I've been asked to write down our full calculator display. So that's going to be 8.9 on the numerator, and then on the denominator, multiplied by 2.8 to the power of 4. And whenever I do that, I get an answer of 0.01591169659. And we've been asked to write our answer to one significant figure. Now we ignore the 0 points at the front, so we're either going to have 0.01 or 0.02. Now the digit after the ones is 5 and then 9, so as you can see that's closer to 0.02 than it is to 0.01. So the answer is 0.02. So we've got question number 19, it says calculate 13.2 plus 88.97 over 2.6 cubed. And whenever we type that into a calculator, we get an answer of 5.81304051. We've been asked to write our answer to two significant figures. Let's see if we're going to be 5.8 or 5.9. This is going to be closer to 5.8, so our answer will be 5.8. And that's it. Question number 20, we've got, again, a fraction, and we've got 183 plus the square root of 89. And on the denominator, 10.8 multiplied by 992.75. And whenever we work that out, we get an answer of 0.01794808483. And the question says to write our answer to four significant figures. So we've got 0.0, ignore those, and then we've got 1794. So the answer would be either 0.01794 or 0.01795. And the next digit is an 8, so we're going to round up, so the answer would be 0.01795. And that's it. So let's have a look at question number 21a. We're asked to work out 13 squared divided by 0.2 cubed. And whenever we do that, we get an answer of 21,125. And we've been asked to round our answer to one significant figure. So let's see if we're going to be 20,000 or 30,000. So the answer will be 20,000. And that's it. Okay, question 22. Question number 22 says, in a box there's 300 sweets, correct to one significant figure. So we've rounded this to the one significant figure, so that's one digit followed by zeros, and we've got 300. And we've been asked to write down the lowest possible number of sweets in the box. So because this has been rounded to one significant figure, we could have had 299. We could have had 290, that would round to 300 to one significant figure. We could have 260. We could have 255, that would round to 300 to one significant figure, because obviously if you had 255 and you wanted to round that to one significant figure, it would be 300. We could have anything as low as 250, because 250 rounded to one significant figure would be 300. 249 though would round down to be 200 to one significant figure, so the lowest possible number of sweets in the box would be 250. Okay, part B. Part B says write down the greatest possible number of sweets in the box. So again, the number of sweets in the box has been rounded to one significant figure, and we know there's 300. So there might be more than 300 sweets, there might be 301. When we round that to one significant figure, that would be 300. We could have 320. If we rounded that to one significant figure, it would be 300. We could have 340. Whenever we round that to one significant figure, we would get 300. We could have 349, because if we rounded that to one significant figure, it would be 300. But we couldn't have 350, because 350 rounded to one significant figure, we round up to 400. So that wouldn't work, but 349 would, so the answer would be 349. So the lowest possible number of sweets in the box is 250, and the greatest possible number of sweets in the box is 349. Okay, let's have a look at our next question. Question number 23. So question number 23 says the population of a city is 160,000 to three significant figures. So we know that this number rounded to three significant figures is 160,000. So that means that the 1, the 6 and the 0 are significant. So it's been rounded to three significant figures, so 160,000. And we've been asked to write down the lowest possible population for the city. So in other words, what's the lowest possible number that whenever we round it to three significant figures would round up to 160,000. So we could have had 159,900. If we round that to three significant figures, it would round up to 160,000. We could have a lower number. We could have 159,700. If we rounded that to three significant figures, that would be, we would round up to be 160,000. So again, that would round up to 160,000 to three significant figures. We could have something even lower. We could have 159,500. And if we rounded 159,500 to three significant figures, that would round up to be 160,000. 160,000 because the 5 would round the 9 up, and then you would have 160,000. But we couldn't have 159,499 because if we rounded that to 3 significant figures, it'd be 159,000, not 160,000. So that means the lowest possible population the city could have would be 159,500. So 159,500. That's the lowest possible number that whenever we round it to 3 significant figures would round up to be 160,000. Anything below that would round down to something lower. Okay, now we're asked to find the greatest possible population of the city. So we could have something bigger than 160,000. We could have 160,001 person, and that would round to be 160,000 to 3 significant figures. We could something even higher. We could have 160,400. We rounded that to 3 significant figures. Again, because it's a 4, we wouldn't round up. We would keep it as 160,000 rather than going up to 161,000. And then we can have anything as high as 160,499. Because whenever we round that to 3 significant figures, because we still have a 4 in that column, in that 4 significant figure, it wouldn't round the next one up. So if we were to round this to 3 significant figures, we would get 160,000. However, we couldn't have 160,500 because as soon as there's a 5 in that column, it would round up to be 161,000. So that wouldn't work and that would work. So the greatest possible population for this city would be 160,499. And that's it. Okay, let's have a look at our next question, number 24. Okay, question number 24. So this time we've been given a number in standard form and we've been asked to round it to 2 significant figures. So we've got this number in standard form, 5.791, and we're multiplying it by 10 to the power of 5. So that means we want to move all the digits 5 columns to the left, because whenever we multiply by 10, which is 10 to the power of 1, we move the digits 1 column to the left. If it's 10 squared, we move it 2 columns to the left, and so on. So we want to move all these digits 5 columns to the left. So let's look at the 1. If we were to move it 5 columns to the left, it would move into the hundredths, then the tenths, then the ones or the units, then the tens, and then the hundreds. So the 1's going to move into the hundreds, so we're going to write 5791. That's in the hundreds, so then we'd have our tens and our units. So that means that 5.791 times 10 to the power of 5 would be 579,100. So we could move all the digits 5 columns to the left. Some people like moving the decimal points to the right, so that means that we'd move it 5 columns to the right, or 5 places to the right, so it would go 1, 2, 3, and then you put on 2 zeros. So we've written this number, the standard form number, as an ordinary number, but we've been asked to round it to 2 significant figures. So that means we want 2 digits followed by zeros. So that means our choices will either be 570,000 or 580,000. Now this number is much closer to 580,000 than it is to 570,000, so the answer would be 580,000. And that's it. Okay, let's have a look at our last question, question number 25, and we've been asked to round 1.48 times 10 to the power of negative 4 to 1 significant figure. And we've been asked to give our number as an ordinary number. So we've got 1.48 times 10 to the power of negative 4, and we want to write that as an ordinary number to begin with. So we're going to move, because it's a times 10 to the power of a negative power, it's going to be a smaller number. So we're going to move all the digits to the right, and we're going to move them 4 columns to the right. So the 1, which is in the units, so the ones column, will move into the tenths, then the hundredths, then the thousandths, and then the tens of thousandths, and that would give us 0.0000148. And let's just check. We move the 1 from the ones or the units into the tenths, the hundredths, the thousandths, and the tens of thousandths. Or as a student once said to me, if you're changing this standard form number, which is a small number, into standard form, because it's got negative 4, you can just put 4 zeros in the front and let's do 0.00148. Now we want to round this to 1 significant figure. That means we want 1 digit. So we've got 0.000. We're going to ignore those, and we're going to have 0.0001 or 0.0002. Now because it's 1, 4, we're not going to round up, so our answer would be 0.0001, and that's it. So these have been the video solutions to the significant figures practice questions on Corbettmaths Maths. I really hope you found this video useful. If you have found it useful, please like it and please subscribe to the YouTube channel. If you need any extra help on significant figures, if you scan this QR code, it'll bring you straight to the video tutorial on significant figures. Alternatively, you can go to video 279A on Corbettmaths Maths. So again, I really hope you found this video useful. If you have found it useful, please like it, please subscribe, and thanks so much. Cheers. Bye.